What's up guys, Onmaths here, and we're looking at fractions. So OCR's the first one up today, and we're asked to work out 6.5 plus 3/4. Now, what I would recommend almost all the time is any mixed numbers in fraction calculations, convert them to improper or top-heavy fractions. But whenever you're adding, sometimes you don't need to. And this is an example of a question that it might be easier just to set that 6 aside and write it as 6 plus a half plus 3/4. And then what we're going to do is just focus on this bit and then add the 6 on the end. Okay, so to add a half and 3/4, we need to get the bottoms the same. So what I'm going to do is I'm going to times the top and bottom of 1/2 by 2 to get it the same as the 3/4. So if I put my tram lines down, I'm not going to do this with tram lines, I've decided. But what I'm going to do is I'm going to get that half, and I'm going to times top and bottom by 2. And that would make it 2/4. Now it's the same as the 3/4. So instead of 1/2 plus 3/4, we have 2/4 plus 3/4. And whenever you've got the denominators the same, you just add the top. So it's 5/4. Now that's top heavy, so let's convert it. So how many 4s go into 5? 1 whole 1. How many remainders? 1. So now we can rewrite the question as, instead of 6 plus a half plus 3/4, it's just going to be 6 plus 1 1/4. And 6 plus 1 is 7, so it'd be 7 1/4. For 1 mark, I think it's pretty stingy. Right, next one says 4/7 of 63. And the word of in maths, when it comes to fractions, means times. So it just means 4/7 times 63. Now to do this one, we can rewrite that question. Okay, let's do this a different way. The number at the bottom of a fraction, whenever you've got this type of question, is what you're going to divide the number by. So we've got 63, and this fraction saying divide it by 7. Let's pick a colour that comes up. Divide it by 7, and then the number at the top tells you what to times it by. So we're going to do 63 divided by 7, because that's at the bottom of the fraction, and that's 9. And then we're going to get that 9, and we're going to times it by 4, because that's at the top of the fraction, which gives us 36. Now I could have done it the other way. I could have done it as 63 times the top, so times the 4, but 63 times 4 is going to give us a really big number. Then we're going to have to divide it by 7, so we'd have to do long multiplication, and then we'd have to do the bus stop method. With this way, by dividing it, we make it a smaller number, and so when we're timesing it, we can just kind of do it in our head. Next one, show that 4/5 is bigger than 7/9. So whenever you're comparing fractions, you can't really compare them unless the bottoms are the same. So we need to figure out what to make the bottom. So we've got a 5 and a 9. So we're looking at the lowest common multiple of 5 and 9. So you could write out the 5 times table and the 9 times table, etc., until you get to the same in both. But eventually you'll get to 45 in both of them, and that's the lowest common multiple. And some of you might notice that 45 is 5 times 9. That doesn't always give you the lowest common multiple, but it always gives you a common multiple. So we're going to get that 4/5, and we're going to times it by something to get the bottom to 45, or we're going to times it by 9. Times top and bottom by 9. So 4 times 9 is 36, and 5 times 9 is 45, so that works nicely. Next one, 7/9, and again we're going to have to times it by something to get the bottom to 45. We're obviously going to be timesing it by 5. 7 times 5 is 35. Now, to be safe, I'd probably normally write an explanation showing that the denominators are the same and 4/5 is 36 over 45, 7/9 is 35 over 45, therefore 4/5 is bigger than 7/9. Not necessary for this question. The working out shows that 4/5 is bigger, so the working out will give you the mark for it. Find a fraction which is bigger than 1/5 and smaller than 1/4. Now, there's many ways of doing this question, but probably the easiest is to do exactly the same as we did in the last question. Get the denominators to be exactly the same. So lowest common multiple of 5 and 4 is 20. So we're going to get these both to 20 by timesing top and bottom of this one by 4. And times top and bottom here by 5. And you'll notice something in a second. Okay. So one of them's 4 over 20 and one of them's 5 over 20. So that doesn't really help us. So what we can do is we can times top and bottom here for each of these by 2. So we can double top and bottom. Remember, we're not actually changing the value. It's the same fraction. So that becomes 10 over 40. And do the same for this one. And that becomes 8 over 40. So if we look halfway between 8 over 40 and 10 over 40, we can create our answer, which will be 9 over 40. Now, it's not the only way of doing that question. It's just probably the easiest to explain and the easiest to show. There are infinite answers, but for me, 9 over 40 would be the simplest to get to. And for question B and C, what you could have done is converted them into decimals. For question B, that's quite difficult to do. I think 4/5 is 0.8 and 7 over 9 would be 0.7 recurring, so not the easiest. But for this one, you could have converted them into decimals and then worked out what the decimal was as a fraction. I don't think on B and C it's easier to do it that way, but if you're really good with decimals, then that's an option. Next up is Edexcel's contribution, and we've got some quite basic questions, times and a takeaway. So with multiplying fractions even, all we need to do is times the tops and times the bottoms. Simple as that. 5 times 3 is 15, 8 times 4 is 32, so therefore that's 15 over 32. And question B, same method as we did previously. You need to get the bottoms the same, the denominators the same. And so for this one, what we're going to do is have a look at the lowest common multiple of 3 and 4, which will be 12. So we're going to times this by 4, times top and bottom by 4, because 3 times 4 is 12. And we're going to do the same for the quarter. So we need to get the bottom 12. And to do that, we're going to times by 3. And that gives us 3 at the top. So we rewrite the question. Instead of 2/3, we write 8 over 12. And instead of 1/4, we write 3 over 12. And then what you can do is just take away the numerators. So that would be 5 over 12. Next, we're going to end on AQA question. As you can see from the question number, question 25, later in the exam, higher grade question, but not impossible, not any harder, not much harder than the first question, the OCR question we did. Even though it's much later in the exam, you just need to know the method. And the method for this one would be definitely make them improper fractions, so make them top heavy. And the way to do that is you get the big number, times it by the bottom, then add it to the top. So 8 times 2, in fact, let's just write it out. So 8 times 2, so big number times the bottom is 16. Added to the top will be 17 over 2. Simple as that. 2 and 2/3, right, so big number is the 2, bottom number is the 3, so 2 times 3 is 6, added to the top is 8. over 3. So we rewrite the question as 17 over 2 divided by 8 over 3. Now I said there's something to remember, and that something to remember is KFC. And there's loads of different ways of remembering this, but KFC stands for keep, flip, change. And for some reason people remember KFC. No idea why. Cough. Okay, so we keep the first fraction as 17 over 2. Don't have to do anything to that. We're going to change the divide sign to a times sign. Sweet, times is nicer. And to do that, we have to flip the second fraction. So instead of 8 over 3, it becomes 3 over 8. Simple as that. Now that it's a multiplication, we just times the tops and times the bottoms. So I can times the bottoms nice and easily, which would be 16. 17 times 3 is slightly more difficult. But if we think 10 times 3 is 30, and 7 times 3 is 21. Then 17 times 3 will be 51. So it'd be 51 over 16. But it says in the question, because it's probably worth 4 marks, so it wants it as a mixed number. So we've got this 51 over 16, and we need to convert it. So first thing you need to ask yourself is how many 16s go into 51? And if you're not sure about that, which probably would be the majority of us, we can quickly write down the 16 times table. So first one is 16, then add 6 would be 22, add 10 would be 32. Then add 6 would be 38, add 10 would be 48. And you can see that if we add another 16, that would be above 51. So that's 1 16, 2 16, 3 16. So there's 3 16s there. So we're going to say 51 over 16 equals, so there's 3 whole ones make 48. So how many remainders? Well, 51 take away 48 will be 3, and keep the bottom the same. So it's 3 and 3/16. Well, I hope you found that useful. If you did, please click like. If you want to see more from us, we release videos Monday to Friday, every weekday. So click subscribe to make sure you're up to date. If you want to see more free resources from us, everything on our website is completely free, onmaths.com, and I'm sure there's a card that will appear at the top of the screen now. Thank you very much for watching this video, and I'll see you tomorrow.